trough somewhere through here maybe. But there's other features in here you might think about as troughiness. And if Dr. was more precise, I would come right through the little bumps in here, but you know, it's good enough for government, or if there's a trough in here basically. And so let me just do that. And let me add the surface wind vectors. This is kind of sweet. And I'm going to back off. This is kind of cool. So this is what the Weather Service is, Cassie, looking at today. So let me leave sea level on, sea level pressure wind. Let me get the reflectivity off. And actually, I'm going to get rid of the pressure for a second. Too much pressure. And then basically, all right. So let's just zoom in. So Jason and gang. So the HRRR is interesting. So what can I do here? I'm coming down, 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 down. All right. So what do we got? Look at that westerly flow. So there's some cool features. This is basically HRRR winds at 10 meters, about 30 feet, Kelly, above the ground. These are forecast from that model a couple hours out, and then I'll step you through them. But let me show you some cool features. So there's a nice ridge in the middle of the Gulf of Mexico near the surface. And so that's weird. That's showing up here. You can see the flow here is very nicely clockwise, anticyclonic here. So looks like there's a nice high pressure ridge out over yonder. Rudy, check this out. So this is the westerly flow the Weather Service is talking about. So pretty decent westerly flow basically at 11 o'clock this morning. And ZWAT in the HRRR basically by 11 o'clock this morning, you can even as far south basically as Palm Beach County. Basically see off, this is all, look at all on the coast. This is all offshore flow. All the winds are westerly, all the way up the coastline this morning basically from the HRRR. And even down in South Florida basically, the flow is still offshore. And so let's step this through to see if we can see any sea breeze development. And all right, stepping it through. Nothing yet, still offshore in our region. It looks like, let me go back here, Cassie and gang. So it looks like something's going on in Southeast Florida. Watch the winds offshore here. So if you watch basically this region here, it looks like the westerly flow is weaker in this region, so they may get a sea breeze. And that's why basically the Weather Service, Rudy and Jason and rest of the gang and Emma and Anna, that's why the Weather Service was talking about somewhere along, maybe you might get a sea breeze formation basically south, but in the region where the westerly flow, basically you can see the wind barbs here are pretty strong. So this part of the coastline, probably not so much. It's gonna either pin it back or not form at all. If the flow is strong offshore, you won't see anything. So let me march this through and take a look at what they're looking at. So yep, watch the winds, ZWAT and gang, I'll go back. So it looks like basically you're getting a response from the peninsula heating. So this basically is 13, this is 1 o'clock this afternoon. This is 2 o'clock. This is 3 o'clock. This is 4 o'clock. So it looks like you can start to see a sea breeze basically definitely form. I can definitely see on this image, essentially, if you look all the way up basically as far north as here, it looks like some definitely onshore flow out of the southeast. But up in Brevard County, nope, still pretty good westerly flow. So it looks like really the southern portions of our forecast domain, gang, it's kind of going to looks like you may get some sea breeze penetration, you may not. Still a pretty decent westerly flow here. Again, this is essentially 4 o'clock this afternoon. So if you don't have a sea breeze by 4 o'clock, you're kind of out of luck, right? Anyway, because you're pretty much pushing max heating. You can get late passages, and so we go into the evening basically, and according to the HRRR, really does not look like Brevard County is going to see much in the way of a sea breeze penetration if you believe the HRRR's depiction basically of that feature. Okay. So what else did I want to show you today in the spirit of the discussion basically? Let me clear that baby up. And so what else is going on? I'll go back to my precipitable water vapor now, which I wanted to show earlier. And I'm going to zoom back out on the feature here. So you get a big, large scale view of this PWAT. ZWatt. I can't help it. Anyway, and so basically what does Dr. L have going on here? I'm going to get rid of the wind vectors basically. And I have a scale up here. So oftentimes precipitable water vapor, Anaham and Emma and Josie and rest of the gang basically is not something that we do in inches, but you can, depends on what you have, but you'll see it in both inches and millimeters. And so basically we're looking at essentially 70, up to 70 millimeters. I changed the scale essentially. And so you divide by 10 to get centimeters, right? So this is about basically 5 centimeters, 2.54 centimeters per inch. So this is slightly less than 2 inches. So 2 inches of precipitable water vapor that they were talking about in the Florida soundings, somewhere a little over 2 inches, is going to be somewhere between 50 and 60 millimeters of precipitable water. And you can see on here clearly that's the case. The other cool thing I really do like and is that it looks like the trough. So it looks like that trough is this low pressure, right? Where you have lots of rising motion, high relative humidity basically, is also quite moist. Conversely, the ridge axis, I go put that back on, which is right over, this is awesome, which has a history of subsidence basically, right? So it's not talking much to the water surface if the air is coming from aloft. Look at the PWatts basically in the water column above the ridge, the surface ridge in the Gulf of Mexico. They're low, they're well under, so there's quite a gradient, kind of cool, right, ZWatt? Kind of cool, there's quite a gradient basically in the precipitable water vapor in the water column basically. And I guarantee you if we looked at surface dew points, Kelly and gang, they wouldn't change much from Florida where you see high precipitable water and the basically Gulf of Mexico, probably not. But somewhere right above that surface, you have descending air from aloft that's pretty dry, right? And probably fairly low relative humidity as well. And it shows up really highly correlated, even though PWatt's an integrated quantity. It shows up pretty nicely with the anticyclonic curve flow, basically, in the wind field. And if I back off for a second, basically, and pull off the, again, the pressure again, you can actually also see the surface trough showing up very nicely in the wind field. And if I zoom back in a little bit, basically, especially north of us. So south here, not so much, but the surface trough, you can see some pretty good northwesterly flow, basically, through portions of South Carolina and Georgia. There's the base of the trough, and the winds basically turn direction out of the southwest. So a pretty nice cyclonic curvature here in this region of the flow field as surface flow field. So kind of cool there. Anyway, back to the PWatts. So I thought this was really cool ultimately. And you can see their highest values basically. If I back up, when they go back, you can actually see this trough move through in the PWatt field, right? So it's just kind of cool. So this is back to about 11 a.m. this morning, basically. And you can see this trough axis, what shows up nicely is this orange basin here. Again, the winds are agreeing well with that feature. I'll take them off, but you can actually see it just does not take that much of an imagination. This sort of basically troughiness and all the higher precip water vapor, especially north of the line that I've drawn. You can actually see this drier air south of here extending from that ridge basically in the Gulf of Mexico, basically across the peninsula. So kind of nice. Yeah, so it even noses its way. So the PWatt values in the Lake Okeechobee region basically are a little bit lower. So a little bit less moisture to work with down there today. The highest values, it looks like, this stuff here is actually just part of the convection. So all these little bullseyes in here are all part of the convection. So if I actually were to put on a composite reflectivity like that and went back and forth, there'd pop, aha. So all those little bullseyes in there are the convection. And so the areas that are more smooth are really just atmospheric undisturbed values of integrated water vapor in the column of the atmosphere. Okay, so what else does Dr. O want to rant about today? So that's the cool stuff going on, I guess. And and so the other thing I have is one more satellite image. You know, we're all used to looking at these guys. These are awesome to look at. You can clearly nicely see Lake Okeechobee showing up as a dark spot. So we come back to this one again. This is kind of, I just love these sort of kind of features. And so I have to just move you guys around here for a second. And if I come over here and move this down a little bit, we can take a look more closely in our region. It's just usually beautiful if Dr. L zooms in. And so let's go into the eastern quarter. I just love these cloud streets. The features in the visible satellite image are just spectacular. What I really love about these things is, for one thing, during the daytime heating, land heats a lot faster, right, guys? Heats a lot faster than the water temperatures do of Lake Okeechobee. I'm sure Lake Okeechobee is the bathtub, but they still will lag the land surface temperatures this time of year as the sun comes up. And so as my blue ball of existential bliss rotates anticyclonically here, it's done. I just wanted to paint out how beautiful the lake shows up. Oh, look at this. I'm getting pretty good at this. Pretty scary. I know, don't quit my day job. Anyway, and so the lake's showing up really nicely. So what's going on there? Well, the land's heating up. So what do you got going on there? So, you know, Dr. L, it's hot, H-O-T. Can I spell? Yes. And then if I got really fancy, I'd go ahead and change colors, but I'm lazy. So it's cooler over the lake. And so, and I'm using this term ZWatt very loosely, cool, put power quotes on them. And so what's happening, basically, a couple of interesting things are happening. I'm guessing the surface flow, I mean, by the cloud field that's developed, basically, it's hard to tell exactly, but the surface flow definitely looks like it has a westerly component because there looks like a suppression of cumulus on the downwind side of the lake. Right, so that stable air at the lake basically is being moved, relatively cooler air is coming off the lake downwind. But the other thing, of course, what I wanted to give you the guys a big picture of is that in the absence of any background flow at the surface, you know, you have basically air leaving the lake surface and heading out, running for its life in all directions, basically towards the hot land surface or hotter land surface. So that's going to produce this kind of basically, or let me just do this in the I'm just doing a separate little graph basically. So you're going to basically, Colin and gang, get sinking motion over the lake, something like this. And if you have sinking motion over the lake, you're not going to get much in the way of cumulus. So the lake tends to be a dark spot basically as a result. So that's kind of cool. If I went back on here, I am curious. You know, what do they say about curiosity killing the cat? Yeah. So this is also no surprise. You can barely see this. Not my intention, of course, but it's just the way it goes. I could change. Let me just be goofy here. Control. Let's see. Control X. Clean that up. Let's change blue. This is always a dangerous thing, to green. There we go. Or yellow even. Or we're having fun at it. I love coloring books. All right, so anyway, so this is the corresponding wind field basically. And again, my intuition was correct. So again, ZWatt, here's Lake Okeechobee and Emma, and the flow basically north of the lake is out of the northwest. And the thing I was trying to point out is that downwind from the lake is this sort of shadow, right? So Dr. L sees a bunch of cumulus basically here, and see some cumulus in this, lots of cumulus development along the southeast Florida coast, but it looks like downwind of the lake, there's some suppression, right? So not that Dr. L is in favor of suppression, but nonetheless, basically, it looks like there's some suppression downwind of the lake as well. So neat features. So what I wanted to wrap it up with then is just to show one last feature here today, and that is basically turn the true wind vectors off, and then go back to the this is another look at the atmosphere. So you guys saw a visible satellite image. This is an enhanced, and these are tough to do, but this is an enhanced. I'm going to back it up. That I didn't realize I had such a small footprint. So let me increase the footprint size here, and hopefully it's going to give me, there we go. So this is water vapor, or water vapor. So this, if you're, so anyway, so this is water vapor. So a couple of things really quickly are kind of nice. Really neat image. And so this is temperature. And so the warmer colors basically is basically the satellite seeing radiation from the atmosphere, wherever it's coming from, whatever footprint, whatever it's looking at below, scanning, okay? And Cassian gang, basically, what does that mean? Well, it looks like, and this is a swath here anyway, kind of like drawn out really quickly. So there's kind of a warm region here that the satellite's seeing, except for the exception of some cloud development here. This is the cluster of convection with high cloud tops. So these really cold temperatures, these are cold. These are minus 70 degrees C. These are cold cloud tops. This is the tops of the thunderstorms, the overshoots, the cirrus, the anvil portions of the deep convection. But this region, basically, if I go back and forth, basically, is clear. Kind of awesome, right? So you're seeing, you would see down to the ocean surface in this region if you were looking in a channel that was an atmospheric window, okay? So if you're looking at a channel with little absorption, right, the radiation coming up from the surface, if there's absorption between the satellite and the surface, right, in the atmosphere, what I'm talking about, somewhere between the surface of the ocean and the satellite, you are not going to see radiation from the surface. So this channel that we're looking at is a water vapor channel. And so you're looking at basically, essentially a signature from the atmosphere, water vapor absorption, basically, of radiation, basically, in the atmosphere, and emission to space, as seen by the satellite. So these warm colors, you're not seeing the surface, you're seeing somewhere in the lower to mid troposphere, basically, in this one image, mostly lower portions of the middle troposphere. The warmer the colors, basically, that satellite has on this image, the closer to the surface you are. Temperatures decrease with height. So this is that warm upper level ridge, basically. What I wanted to show you is the correlation between this image, somewhat anyway, and the precipitable water vapor. If I go back and forth, where did I do it? That one's off. So if I go back and forth to that one, basically, what happened, I need to move it through here, hold on. I thought I'd get rid of that one. There we go. So it's not highly correlated, but not too bad. Let me move this forward. There we go. So if we take a look at this for a second, and Dr. L goes back and forth, I guess there's that image. And oh, I see. It's just going to jump around though, or not. Let's see. Hold on. I don't want that. I'm out of control. All right. So there you go. So I was talking about, right? So this tongue of drier air, correlates, interestingly enough, right? This is lower precipitable water vapor, right? So this sort of swath, I guess, Control X, let me clean that up. So this, again, I'll just go ahead and highlight this real quickly. And then, again, so there's a nice big blob of sort of drier air in this region. If I go back to the water vapor image, not totally correlated, you have to be careful, but not bad. And so some of that dry signature basically means you're seeing basically deeper into the atmosphere. Okay, so again, lower precipitable water vapor, right? And if you go back to the IR image, you're looking at warmer temperatures. Not one-to-one, but definitely somewhat related. So I just wanted to kind of point that out. When you take remote sensing, for those who haven't, when I teach the class, I talk a lot about sort of these kind of applications. Don't yell at me, guys, to remote sensing. So anyway, I'll leave it there. If somebody's got some questions, I'll field those now as we wrap things up. Dr. L's stomach is growling. I thought it was thunder at first, but it wasn't. Comments, questions? Was there something you didn't see that I should have shown? I don't know. So that's sort of the weather today in a nutshell, and I put the nut in nutshell, so to speak. You guys are quiet. Is it because Cassie's muted all of you?
No, I didn't mute anyone.
Very quiet. You get her pin drop. Any questions? I guess I could stop sharing. Anyway, I think everybody's on here. So, Cawthor, how you doing? I see a slash through her microphone.
I'm doing well. How are you?
Good. Emma, how you doing?
I'm doing.
Alan, I'm glad you're back on again. Thank you. It's awesome. You get a thumbs up. It's awesome. This was very different than the Saharan dust layer. This is more local. It turns out we ended up getting quite a bit of dust even here in Florida as that plume kind of went up and around and back down to the southeast. It was pretty hazy here for a few days. You guys out in Colorado don't know anything about hazy skies. You guys get the bluest skies out there. It's pretty incredible. Anyway, comments, criticism, eggs, oranges. Nice lightning shot, Jason. Fabian, how you doing? Glad to have you back on too. It's awesome.
Doing good, thank you.
Looking forward to seeing you guys in the fall. The classroom should be fun, minus some details. I don't know whatever else is going on. I don't know. I think that's it. So that's sort of the weather and as it goes. I'm hoping you guys, your summers are going great. Anyway, I'm just kind of no reason to prolong the agony any more than I have already. So anyway, you guys have a good afternoon. Stay out of trouble. Like I tell my students, if you find any, let me, and it's interesting, let me know about it. Okay. Otherwise, I'll be seeing people around and in various capacities. And thanks for the guys who are graduated but joined in. David, it's awesome to see you. Oh my God.
Always.
When did you graduate, by the way? When did you graduate?
What was it? 14, I think. Yeah, sure. We'll go with 14.
See, guys, I didn't scare everybody away. He came back for more 6 years later. I have not seen him. It's been a long time. So anyway, thanks for jumping on. It's awesome. And Cassie, thanks for getting the information out to people that allowed alumni and incoming freshmen and everybody else in between get online with us. So it's good. And I hope your summer out in Colorado is still going well and you're being safe. I am really much looking forward to seeing people in the fall. It'll be kind of nice. I'm going a little stir crazy. I was already crazy, but now I'm stir crazy. So anyway, all right, I'm going to leave, say goodbye. Can you tell I don't want to say goodbye? It's pretty sad. Anyway, you guys be good. All right. And I'll catch up with you. Bye-bye.